Yes, global warming will be bad, but these scientists say it won't reach the worst case scenario. By Chris Mooney, the 17th of January, climate scientists on Wednesday suggested that they may be able to rule out some of the most dire scenarios of what would happen if greenhouse gas levels in the atmosphere were to double. Unfortunately, the same scientists say the best case scenarios are also probably unrealistic. How a doubling of atmospheric greenhouse gases would affect the climate is of tremendous importance, as humans are running out of time to avoid that outcome. With current atmospheric concentrations at 405 parts per million, as opposed to about 280 parts per million before the dawn of the industrial era, the planet is already about halfway there. In the new study in the journal Nature, Peter Cox and Mark Williams of the University of Exeter and Chris Huntingford of the United Kingdom's Centre for Ecology and Hydrology attempt to recalculate the equilibrium climate sensitivity, a highly influential metric that describes how much the planet will warm if carbon dioxide doubles and the Earth's climate then adjusts to the new state of the atmosphere. For decades, climate studies have found a very broad range of possibilities for this key figure, somewhere between 1.5 and 4.5 degrees Celsius, with 3 degrees Celsius, or 5.4 degrees Fahrenheit, sitting smack in the middle of the range. But the inability to further narrow this estimate has been a big problem, Cox said. The problem is the low end sort of implies maybe you don't need to do much about climate change except adapt, and the high end implies it's kind of too late, he said. Recently, however, different teams of scientists have hit upon an approach to try to narrow the results, trying to find an emerging constraint on what the possible future outcome could be by comparing high-powered climate change models, which predict the future, with currently observed elements of present climate. You find something in the models which is well correlated to future response and can potentially be observed in the real world. Ben Sanderson, a climate expert at the National Center for Atmospheric Research, said of the approach. Sanderson was not involved in the current study. To that end, Cox and his colleagues focused on a simple measurement: how much the climate varies on an annual basis, irrespective of greenhouse gas emissions. What we did is look at how the variation from year to year, having taken out the long-term trend, was related to the sensitivity of the system, across all the models, Cox said. The result allowed the scientists to narrow the probable climate sensitivity range to between 2.2 and 3.4 degrees Celsius, with a central figure of 2.8 degrees Celsius, 5.04 degrees Fahrenheit, somewhat lower than the previous central estimate. They said this amounts to narrowing the uncertainty around the figure by 60%. We think the likely range is 2.2 to 3.4, so that kind of very much downplays high climate sensitivities above 4. And low climate sensitivities below 2, Cox said. The study asserted that there is less than a 3% possibility that the climate sensitivity is lower than 1.5 degrees, and less than a 1% possibility that it is higher than 4.5 degrees. If correct, this would be very good news, suggesting that we may not have to reckon with truly hellish temperature increases by the end of this century. I should thank Cox and colleagues for helping me to sleep a little easier in my bed at night. Piers Forster, a climate scientist at the University of Leeds in the United Kingdom, wrote in a commentary on the new study, also published in the journal Nature. Forster also called the new study's methodology ingenious, but the key question is, of course, whether it's actually right. The new finding contrasts with a similar study, also published in the journal Nature, which found that the global climate models that best capture the current climate are also those that predict some of the warmest and most severe outcomes. That study, by the Carnegie Institute for Science's Patrick Brown and Ken Caldera, used a conceptually similar methodology but focused on the incoming and outgoing energy at the top of the planet's atmosphere, rather than annual temperature wobbles, and it actually pushed upward somewhat the estimate for how bad warming could get. Brown and Caldera said they are studying Cox's new research to try to figure out why it differs from their own. Cox, meanwhile, said he saw similarities, as well as differences, with the other team's study. What we both do is say the low values are unlikely, he said. We also think the high values are unlikely. They think they're likely. It's normal for these types of studies to be apparently contradictory, Sanderson said in an email. The way forward is to better understand the physical mechanisms for why the correlations exist. Then we can look together at all the information to make a holistic assessment of all the evidence as it pertains to the real world. It all suggests that scientists have plenty more work to do in figuring out a better estimate of the climate sensitivity. Their best answer will be watched closely when it arrives in the form of the next report of the United Nations Intergovernmental Panel on Climate Change, expected in 2021. In the meantime, getting the number right matters a great deal in the current moment, because it helps determine the chance of limiting global warming to below 1.5 or 2 degrees Celsius. Two key international targets enshrined in the Paris Climate Agreement. Cox explained that with current emissions levels, we are probably committed to a warming that would be about half of the central equilibrium climate sensitivity X number. If we believe the X is 4, we are already committed to 2 degrees, he said. An X of 3 means that the aspirational limit of Paris of 1.5 degrees is essentially about to be passed. An X of 2.8 means we still have the possibility of avoiding 2 degrees. We're very close to 1.5, but we could still avoid 2. If this study is proved correct, it wouldn't change our best guess of what the future would look like under climate change, but it would make the worst-case scenario slightly less catastrophic, Sanderson said. The Washington Post. Democracy dies in darkness.